In this example, he's asking about find the I in the following circuit. Assume all diodes are ideal diodes. So the I is right here, current passing through the 10 kilo ohm resistor. So step 1, similar to the previous example, find the voltage at each node. I'm talking about the node which is open terminal or outside of the outside, which is going to the other elements in the circuit which are not shown in the diagram. So here I can see here is a node. I know the voltage at that point is 10 volts, 5 volt, 2 volt and 0 volt. So first draw the possible current flow directions. So that's one possibility. Okay, and this is another possibility. Okay, so current always flows from higher potential to lower potential. So, and this is another possibility. Okay, now the second case, so current can go from here to here. Okay, and current can go from there to there. The last case, we're going to have current can go from there to there. Okay, from 2 volts to 0 volt. So let me label D1, D2, D3. So if you look at D1, diode D1, every current is going out. So for sure, I mean going out in the sense current is flowing from anode to cathode. So diode always allows current from anode to cathode, not from cathode to anode, right? So for sure, this is acting like a closed switch. Okay, for sure we know that this is acting like closed switch. Now if you look at diode D2, we have one current going from cathode to anode, two currents going from anode to cathode. So this case we don't know what's going on, whether it is acting like closed or open. Same thing with the diode D3. So diode D3, one current is flowing anode to cathode, two currents are flowing from cathode to anode. So we don't know. Okay, now for time being, I'm going to assume step 2. So there are 4 possibilities. Maybe diode D1 for sure closed, D2 is closed, maybe D3 open, or D2 closed, D3 closed, D2 open, D3 open. So there are 4 different possibilities because of the 2 diodes. So do we need to try all 4? Maybe, may not be, depending upon how much experience you have with these circuits, solving these examples. So I highly recommend you to practice as many examples as possible. Okay, so here assume both diodes are closed. Okay, D2 and D3 closed, acting like a closed switch. Okay, so for sure I know that D1 is acting like a closed switch, 10 volt. So what I'm doing, I'm taking these two are also acting like a closed switch. Okay, now what is the voltage at this node? 10 volt. What is the voltage at this node? 5 volt. What is the voltage at this node? 2 volt. Are there any resistances in between? No. This node, this node, this node, everything is same node because there is no element here. Okay, and you are saying at the same node you have different voltages, which is not true. So as I said, it is impossible to have 3 different voltages at the same node. So for sure our assumption is wrong. Okay, so for sure our assumption is wrong. So now what I'm going to do, I'm going to assume, the remaining 2 cases, D2 closed, D3 open, same case, and either D3 open, D2 closed, that's going to be the same case. So they must act like a open switch. So assume D2 and D3 open. So I'm doing the step 2 again. Okay, I'm repeating step 2. So here I'm assuming D2 open and also D3 open. Okay, so now you can see that what is the current passing through this? I equal to 10 minus 0 over 10k, that is 1 milliampere. Okay, now step 3, verify. Okay, what is the voltage at this point? That must be 10 volts, right? And what is the voltage at this point? That must be 10 volts. So if you look at D2, okay, we have 10 volts here and 5 volts there, and we are representing this as open switch, right? So our assumption is right. And D3, same thing, I have 10 volts there and 2 volts here, we are representing this as open switch. That is also right. So our assumption is right. These two diodes are acting like a open switch, and this is the current passing through the circuit. I'm going to solve one more example in this video. Here is the next example. In this example, he's asking about find the I. I is the current passing through the diode D2. Okay, so step 1, I'm not going to write it down. So step 1, find all the outer node voltages. Outer node is nothing but the node which is going to the other elements of the circuit, which are not shown in this figure. Okay, so this is going somewhere else. Something else is connected there, something else is connected there. We don't know what it is. All we know, the node voltage at that point, node voltage here, and we know that this is grounded, so ground voltage is 0. So step 1, we know all the node voltages. Now find all the possible current flow directions. So that is one possibility, current flowing towards 10 volts to 0 volt. Another possibility is 10 volts to 0 volt. Okay, same thing here. One possibility is 10 volts to 0 volt. That's third. And the last one is from 10 volt to 8 kilo ohm or 0 volt, right there. So if you look at D1, okay, diode D1, all the currents are flowing anode to cathode, for sure acting like a closed switch. Acting like closed switch. Okay, D2, one current is flowing opposite, another current is flowing forward. I mean anode to cathode, another one is cathode to anode. So we don't know. Okay, for time being, step 2, I'm going to assume D2 acting like open. Okay, if D2 is acting like open, okay, this is what the circuit is going to look like. Okay, we have 10 volt there, 2 kilo ohm, 8 kilo ohm, 10 volt there, 8 kilo ohm and 2 kilo ohm. Okay, what we're saying that that's open. Okay, now I'll find the current. Let me label this as I1. I1 equal to 10 over 10 K 1 milliampere. Okay, let me label that as Vx. That Vx must be equal to 1 milli times 8K, that must be 8 volt. Same way, I'm going to label this as I2 here. So I2 equal to 10 over 8 plus 2, 10 mil K. So that's 1 milliampere. I'm going to label the voltage here is Vy. Vy equal to 1 milli times 2 kilo ohm. Okay, because I know this is 1 milliampere. So this is 0 volts. So the voltage drop here must be 2 volt. So Vx minus 0 equal to, or sorry, Vy minus 0 equal to 2 volt. So Vy equal to 2 volt. Okay, now what is the current passing through this diode? That must be 0 milliampere. Step 3, we will verify. Okay, when we verify, you're saying this is D2. The voltage at this node, you have 8 volt, and the voltage here is 2 volt, and you are saying that this is acting like a open switch. Is that true? No. If you have anode voltage is higher than cathode voltage, it must act like a closed switch, but you assumed it as an open switch, so our assumption is wrong. Okay, write down here, our assumption is wrong. Pardon me about my writing and spellings. Now what I'm going to do, I'm going to repeat step 2 again. This time I'm going to assume the diode is going to act like a closed switch. Okay, 10 volt, 8K, 2K, 8K, and 2K. Okay, since it is acting like a closed, the voltage at this point must be same. Let me label that as Vx. Okay, what I'm going to do, at Vx apply KCL. Vx apply KCL. So it's up to you, how do you want to take the currents. I'm going to take that as I1 entering, I2 is also entering, I3 going out, I4 going out. So I1 plus I2 must be equal to I3 plus I4. Okay, so 10 minus Vx over 2K plus 10 minus Vx over 8K equal to I3 is Vx minus 0 over 8K plus Vx minus 0 over 2K. To eliminate the denominator, I'm going to multiply this with 8K. So that is 40 minus 4Vx plus 10 minus Vx equal to Vx plus 4Vx. Okay, so 40 plus 10, which is 50, equal to minus 4Vx minus Vx minus 5Vx. Take it to the other side. Here I have already 5, so 10Vx. So Vx must be 5 volt. So the voltage at this point must be 5 volt. So once I find that, I can find the current I3 equal to, let me find I1 first. Okay, so I1 equal to 10 minus 5 over 2K, because the voltage at this point is 10 minus, I know this voltage is 5, we just found it. So 10 minus 5 for 5 over 2K, which is 2.5 milliampere. Now I'll find I3. I3 must be 10 minus, 5 minus 0 over 8K. So 5 over 8 equal to 0.625 milliampere. So I1 current 2.5 milliampere is coming down and 0.625 milliampere is going in the direction. So what is my I? I must be 2.5 minus 0.625, we'll end up with 1.875 milliampere. Okay, so that is the current passing through the diode. Now step 3, still we need to verify, even though we verified previous case. So if you look at D2, what we are saying, the voltage at this point is 5 volt, and you are saying there is a current passing through this diode, which is 1.875 milliampere. Okay, so current is flowing from anode to cathode, which is true. So our assumption is right. I'm going to stop this video here. Next video, I'm going to solve another example based on this ideal diodes. Thank you.